In Thomson's experiment, he connected two metal plates to a power supply and charged one negative and one positive. He was then able to observe what were called cathode rays jumping from the negative to the positive plate. How did he know this? He cut a hole in the positive plate which allowed a beam of cathode rays to go through. He observed them by allowing them to hit a phosphorescent screen, which would glow when the beam hit it. To see if the cathode rays were charged, he then took a second set of charged plates, one above and one below the beam. Of course, when the second field was off, the cathode rays went straight through, as shown by the black line. When the plates of the second field were charged with a small amount of charge, he observed that the beam was deflected toward the positive plate, as shown by the blue line. Notice that since opposite charges attract and like charges repel, he concluded that the cathode rays were negatively charged. When he increased the charge on the second field, the beam deflected by a greater amount, as shown by the red line. The distance by which the beam of cathode rays deflects depends on the charge of the rays and the mass. More specifically, it is the charge-to-mass ratio that determines the deflection. So the deflection of the rays depends on the charge of the particles divided by their mass. Thomson had experimented on other charged particles. He found that the deflection for the cathode rays was much greater. In other words, they had a very large charge-to-mass ratio. Now there are two ways to get a very large ratio, either with a very large charge or with a very small mass. He guessed it was the latter, although the mass would need to be at least 1,000 times less than the mass of a hydrogen atom. In other words, he proposed what we would call a subatomic particle. Thomson's cathode rays are what we now call electrons, although Thomson preferred to call them corpuscles. You should note that the experiment did not prove the existence of electrons, since he could only measure the ratio. He could not actually measure the mass of an electron.